All right. Good morning, good evening, or good night, depending on wherever around the world you are. And welcome to another fantastic episode of Microsoft Learn Live TV. Again, here with my good friend Hasan. Hasan, how are you doing?
Great, Alex. How about you?
I'm very fine myself. Thank you for asking. I'm super excited actually for today. We're going to have a fun topic again. So last week we have talked about indexes and stuff like that. This week we're going to dive deeper into the indexing topic. And I don't know about you, Hasan, because you were the moderator. Did you have fun last time?
Yeah, we got actually great questions, and I was able to, try to answer most of them. But this is a great topic because, well, indexing is always fun. It doesn't matter which database it is, I guess. But yeah, I'm excited.
And so am I, really. I'm super hyped actually for today, because today's topic is literally called customizing indexes in Azure Cosmos DB SQL API. And the reason for I'm so hyped about this is we are actually going to dive deeper, as I've said, but we're also going to cover some of the great topics that we have received fantastic feedback on the previous time. Some people reached out to me personally over Twitter, and thank you for doing that. And by the way, if you want to do that again, I'll be more than happy to stay in sync even offline with you. And if you want to find my Twitter handle, it's going to come up somewhere along my name, as will Hasan's. Hasan, not a lot of people know us, because I know we have a lot of newcomers to our series as well. So why don't you introduce yourself properly?
Sure, yeah. Well, first of all, welcome everyone. My name is Hasan Savran, and I have my own company doing mostly Azure Cosmos-db consulting, and also I'm a business intelligence manager, one of the large insurance companies here in the United States. I'm a data platform MVP. This is my third year, and I'm very happy and proud to have one. Thank you.
Thank you for doing that. And my name is Alex Mang. I'm going to be your host along with Hasan today. I run a company based in Romania, in Transylvania to be a bit more specific, which has been on the cloud and around the cloud and over the cloud, I guess, and whatnot, and under the cloud even for the past 12 years, literally ever since Microsoft Azure was a brand new thing. It was a baby back then. We picked it up, we loved it, and we have went with it ever since. I am also known to be a fellow MVP, just like Hasan. My work category is Azure, and as you know, Cosmos DB has been born in the cloud. So obviously, it's one of my favorite topics and one of my favorite services in Azure as well. Also a member of the Regional Directors Program, and also a tinker of things, including robotics and many others as well. Okay, this was probably the least interesting part of the presentation today. So let's get started actually with stuff. And I do want to say hi to Chris. Chris is going to be our moderator today. Chris, a fellow MVP on the data platform and work category. And a lot of people don't know about this about us, especially the non-MVPs who are following us on YouTube and Twitch, Microsoft Learn, and wherever else, to which we say hi, and we would appreciate a hi back in the chat window. This is the MVP Summit week. So I guess kudos to us for being MVPs and not attending the fun sessions where we could learn a lot more. But I'm super passionate about actually sharing more my knowledge and my passion here with Cosmos DB, and Hasan, I'm pretty sure you are as well.
Yep, same here. Thank you for joining us today. And I know actually Chris, I used to see Chris many events in older days before the COVID, so it's kind of nice to see him here too.
I'm looking forward to in-person events. At some point, it will happen. I trust that it will happen again at some point. And I do say hi to the the army of people really behind this series, who are producers, program managers, principal program managers, to which we do say hi, and we thank them for this fantastic opportunity. Now, as I've said, this is a series, and today's episode, I believe this is the 12th. I might be wrong. We're somewhere around that number. Today's episode is going to focus on customizing indexes in Azure Cosmos DB SQL API. And as many people know, especially those who are not newcomers to our series, we are actually following the curricula for the DP 420 exam, which is on developing Azure Cosmos DB-based solutions, obviously on Microsoft Azure Cosmos DB. And today we're going to cover the module which has the same title, Customize Indexes in Azure Cosmos DB. Now, whilst I do encourage everyone to head over to Microsoft Learn and get their hands dirty and work at their own pace, I do not encourage people to do that whilst we're recording, especially today, because we're going to have a lot of more tips and tricks on how to utilize indexes and how to leverage them, how to tune the performance, how to troubleshoot performance issues that you might have on whether indexes are utilized or not. So there's going to be a lot of fun demos coming from Hasan that will also share a lot of cool tips as well. And as I did mention previously, this is actually following a certification. Hasan, did you get certified yet?
Not yet, but I start to actually see people getting results for the exam, and many people are happy. So it's good to see that many people actually took the exam.
That is correct. Actually, the exam just came out, I think, roughly a week ago out of the beta phase, which means that whoever took the exam during the beta phase and passed is going to receive their congratulations anytime soon. And as well, if you want to take your certification, you can go right away, take your shot to it, share all the knowledge and their passion, and just take the exam and hopefully pass it as well. And if you do pass it, please let us know. We'd be more than appreciative to know if this series helped you in actually passing your certification exam as well. Good. That being said, I do remind people this is a live session. It's live TV, right? So we really love the interaction. I know it's not in person. It's the best we can do at this point. With the entire COVID situation around the world. But that being said, let's not be strangers. Just come over to your chat section in Twitch, YouTube, Microsoft Learn, wherever you are. Just say hi. Tell us where you're from. And whenever you have a question, Chris will make sure to answer your question, and we'll also take some questions from the audience, read them out loud, and have them answered to our best extent. Hasan, what are our learning objectives today?
So we are going to look at the indexes today and try to create indexes and, maybe run some queries and see how actually they use the indexes, in what cases I guess they use, in what cases they don't use it. And also I will kind of look at geospatial data and show you how actually index those properties too.
That sounds very interesting, because especially last time we have not talked too much about the geospatial indexes. So I'm looking forward for that part as well. So as applications, generally speaking, mature, developers end up in this place where they have the ability of customizing the indexing policies to pretty much better match the needs of the solution. What I appreciate very much about Cosmos-DB is the capability of pretty much changing these indexes on the fly. But at the same time, I've also realized by using Cosmos-DB over the years that many times I'm changing the indexes and they don't immediately get applied. It's not necessarily recognizable, at least not from the first stance. But if you do get your hands dirty a bit, and if you do look at your query stats and whatnot, you will actually learn what works and what doesn't work, and what gets applied and what doesn't get applied. So in this series today, we're going to actually cover more tips and tricks on how to utilize them, how to leverage range indexes and quality indexes and composite indexes, of course, and whatnot. But I've also learned from the previous episode that it might be a good idea, just at least briefly, to go through the indexing topic one more time. So Hasan, if you were to explain indexes really, really quickly, how would you explain indexes as if I were 5?
So indexes are, how do I guess explain indexes? So it's kind of like a challenge, especially in Cosmos DB, because if you are like in a relational database, right? So you have DBAs. So as a developer, you create your table and, you may put some primary key on it and you kind of give the DBA, and DBA looks at the schema and maybe, some indexes for you. In Azure Cosmos DB, as a developer, you are kind of responsible for that. You might not have a DBA waiting for you to actually help you. So it is pretty important to kind of know about the indexes. So if you are, if you're a developer and you're thinking that this is going to same thing is going to happen just like the SQL server, that might not be the case, because there's not even that many DBAs out there for Cosmos DB. So I guess as a developer, I will suggest you kind of look at those topics and kind of try to learn them, because you like or not, this might be, like on your plate, and you may need to actually do indexes on your Cosmos DB solutions. So when it comes to the index types, right now there's only like 3 of them. One of them is the included path, which is the, the range indexes. composite index, which if you have a lot of, if you are querying by many properties, which happens usually, composite indexes actually can help you. Also, if you want to use the order by with multiple properties, you must have the composite index, because without that you cannot do that in Cosmos DB. And geospatial data, that is, if you have the geospatial data in your data set, that will help you a lot with the request units, for sure.
Yeah, I think that's a good point, and it is indeed, as you have mentioned previously, difficult for Cosmos DB to define indexes, especially through the way they're implemented. Generally speaking, if you're in the relational world in your father's or grandfather's SQL server, defining indexes or explaining it to a 5-year-old would be just taking this book and telling them, hey, you want to understand what an index is, just look at the end of the book, and for every word you're going to find a reference to the page where you're going to find that word at, right? And generally speaking, in most relational databases, indexes are going to be designed mostly or architected as a binary tree. So that's going to be super, super straightforward and super, super simple. In Cosmos DB, things do get a bit more tricky because they don't have multiple indexes depending on the type of the attribute and the property that you're going to work with, but rather they have a single so-called inverted index. And a lot of people need to wrap their head around this concept because it is a bit difficult. The idea is that when you start with a new Cosmos DB container and you're using the core API and Cosmos DB, really, you start out with a range index, aka an included path. A lot of people refer to this index as the range index. I'm not a major fan of that reference because I don't know, maybe it's just my mind, but it kind of makes me think that the range index only gets applicable for when you utilize a range filter, but it couldn't be any less true. Range filters, equality filters, the difference of an equality filter is A equals or X equals whatever value. A range filter is X rather larger than whatever other value, right? They both get covered by the same type of an index, which is so-called an included path, aka a range index. And that's going to be super simple and straightforward for most of the queries and the scenarios that we can work with. But sometimes, as you have mentioned, Hasan, sometimes you got to go the extra edge, right? In some scenarios, you're going to have complex filter expressions, using an aggregate, using order by, using sorting effectively, right? And that's the place where composite indexes make more sense. And of course, if you're running like a spatial system function in Cosmos DB, spatial indexes are going to be great for that, and they can definitely help improve performance. Now, hey, how do you know why the default, for instance, because this is the default configuration for indexing policy, right? I've always wondered, do you and Hasan know? I asked this question the previous time. Do you know why we have this very ugly looking E tag description right there? And I promise the audience, I've tried my best to find the reasonable answer for Stack Overflow and other resources. I personally couldn't find it, but maybe you know.
So since E tag always changes with each update, it really doesn't make sense to kind of, I guess, put it in the index file, because the last thing you want to do is, change your index file if you don't have to. In this case, you really don't have to, because E tag is always going to change, and you just don't want to go to index file and change it every time it changes. I guess that is my guess.
Oh no, you're spot on. I mean, the reason for why you're excluding by default E tag is that particular thing. E tag, as a quick reminder for everyone, is how we handle consistency effectively, or concurrency, optimistic concurrency in Cosmos DB specifically. What that means is that every time your document updates, maybe there's an update, a partial update or a full update on the particular document, the E tag value, which is a system property, you don't write it yourself, is going to be automatically updated. And we use this for optimistic concurrency, so that in case you have multiple consumers or handling the same document, and then both of them trying to update the same document at once at the same time, obviously nothing will be at the same time. So one will be at least a microsecond faster than the other one. So once the second request comes in from the other consumer who had previously some dirty orphaned data, let's say, their update is going to be prevented from being committed, because they don't have knowledge of the actual latest value that actually exists in the container. So the way you write your code is that you have to update that value. So that's the reason for the existence of E tag. The reason for excluding that, just like you've mentioned so fantastically well, Hasan, is since this value gets updated so often, we don't want to constantly update our actual index, our inverted tree. What I don't know, however, is why we're escaping e-tag in that crazy, ugly-looking way we are. Like, we're escaping the quote and the quote again. Like, I don't know why that happens, in all fairness, but this is the way you have your indexing policy defined by default. Yeah, but that being said, that's the reason for why I exclude e-tag. I would personally, most of the times, exclude the timestamp as well. And I usually do that, in all fairness. Now, when it comes to actually configuring an index, the way you go about it most easily probably is go through the Azure portal, then just open up the Data Explorer section, head over to your rightful container, go over to your scale and settings section, and then just configure the indexing policy under the indexing policy tab. Now, here's the deal, however. When you look at this index, as I've mentioned previously, this is like the default index that you're going to work with. So when you work with this index, as you see, there's an included path and excluded path section. And it's sometimes a bit tricky to understand why we want to include everything and exclude particular properties, or the other way around. Again, the e-tag property there is used for a reason which is a separate reason from the rest of the data in Cosmos-DB. As I said, the e-tag is just used for optimistic concurrency. So if you're like building an application that does many updates, constantly utilizing RU on something that you're most likely not ever going to have a filter on is just waste of RUs, right? So you don't want to spend that money on something that you're going to waste anyway. And frankly, it's just dumb. So put differently, you end up spending money on indexes that you never really use. So that's the food thought here. Unfortunately, it makes the default indexing, however, also look ugly, because you have this e-tag property, and it not only looks ugly because, well, it's more explicit, but also because of that double quotes escaping that is necessary. I didn't tell you much about the sample I'm going to show you here, though. So let's imagine you have a container where you hold employee information. And for a more specific use case, we're going to have a document which represents Mark Brown, who lives in on 123 Cosmos Road, works for Microsoft, and is a product manager. So with the default indexing policy, every single property will be indexed. And you see them right here. We will index the name, we'll index the address, we're going to index the company, we're going to index the job, and we will also index some system properties which Cosmos-DB always defines for every document, including the identifier as well as the timestamp. And this happens even if you haven't defined explicitly an index for these properties because of the asterisk that you see right here. Now, if I were to go and optimize my indexing policy to only include the necessary paths, we're going to have the name and the address properties included, and my policy would look pretty much like the one that you see on the right, on the left-hand side. And additionally, as you might tell, I also chose to explicitly exclude every other property which is not included. So for this particular document, this would translate into indexing, well, the identifier, the name, the address, and then excluding everything else, included, which means the company, the job, and the system properties. And you might ask, why would you do this in the first place? So the short answer is trying to optimize the right performance for every property that you don't need an index for. And specifically, by not indexing the information that you're not going to filter against, we're going to save our use at the right time. So the optimization won't be necessarily done to increase the performance, so it won't make the query faster, but it will make it cheaper to go and write and even update some different documents. Now, here's the deal with this change. In this example, let's imagine we have a new property, and we add a new property called age. And with the indexing policy, the age would start from the start would not be indexed because we have opted to put a / on the excluded path, right? This implies that the age property we just added in the document is excluded. So basically, we're still indexing the ID, the name, the address, but we're excluding every other property, including the new property that we added. So simply put, when you explicitly include some properties but leave everything else out, any net new property will not be indexed. And sometimes this isn't the intended behavior, but sometimes it is not. Another option, Hasan, if you would pay for a second, just close attention to what I'm doing here, is that I'm going to flip the policy. Now, Here I have everything flipped. What this means is that I'm explicitly excluding company and job, but I'm including everything else. And I'm just doing this for the sake of the demo mostly, right? But the idea is that if you specify to include everything, except for specific properties that we're specifying, you're effectively allowing any new property that you're adding to your data model to automatically be indexed. I wonder what is your case, and I'm eager to learn more. But when I talk to customers, they usually ask me if they should, by default, include or exclude. And I believe that the right answer generally is it depends, because I consult them. And I do fancy the approach, however, of including everything by default, because if you add a new property, you then have to explicitly go and add it to your indexing policy and rebuilding your indexes. And maybe it's just me, but when I have to reindex policies, I usually do it on a basis where this happens, say, every other month, or maybe after 2 or 3 or 4 months. And by doing so, I sometimes forget on updating my indexes because of the new property, right? So, but instead, if you include everything by default and exclude specific properties explicitly, you're kind of future-proofing that you should every time your model changes, everything will still work without you having to go through the indexing policy changes. Hasan, what about you? Do you include everything by default, or do you exclude everything by default?
So since, if you're coming from the relational database, it really makes sense to include everything, because that's how everything kind of works. You just pick what you want to index first. So, that kind of makes sense. But after a while, it makes more sense to kind of exclude. So other way, you are saying that, where you don't want to pay money, because at the end, that is storage we are talking here, right? So
Yeah.
if you are going to have like a big chunk of text and you are never going to, I guess, search by in your where clause, it might just make sense to exclude that and keep everything in the included path. So if you have a new property comes up later, it will be indexed. So you don't have to go back and re-index the whole thing, because, well, you want to kind of use everything in the included path, and you didn't define the new property that you just introduced in JSON. Since we don't have a schema, you can have new properties coming up. So I prefer to go with the excluded paths. I think that works for me and for my customers better, for sure.
So it seems like we're on the same page on this one. And you've mentioned previously, if you have a big chunk of text, even though this is not the right time for that, because we have a dedicated episode coming up in a couple of weeks, I believe, there is the ability of actually integrating Azure Cognitive Search with Cosmos-DB, which would give you the ability of doing like semantic searches and stuff like that on a big chunk of text. Imagine that would be like a product description, or maybe a document. Even handwritten documents could be part of that as well. And you would have cognitive search effectively understand the handwritten and implement an OCR system, object character recognition system, or optical character recognition system, and have that actually implemented in the full text-based search mechanism prior to actually doing, I don't know, the equivalent of a like in Cosmos-DB and utilizing indexes that would be much more expensive otherwise. I guess one of the key takeaways, irrelevant whether you include everything or exclude everything by default, is to remember that by what you're doing when you're including or excluding is that you're ensuring that you're not wasting RU, but you're not optimizing your query performance, right? Specifically, you're not making your query faster by being more specific with the properties that you're including. And this applies even to cases when you either explicitly include everything or exclude everything. And actually, there's another interesting thing with Cosmos-DB, because when you add a new property, especially if you're coming from the relational world of SQL, you might expect that adding properties would enforce the index to be rebuilt, right? I mean, that's the way SQL Server works. Well, in Cosmos-DB, it does not. That's because Cosmos-DB uses a concept of an inverted tree. And what this means is that they're effectively saving the index so that it effectively adds a leaf to the tree, and that gets added as part of the index every time you change something to the index, like you add a new property, for instance. And I know how Microsoft even ourselves, I'm doing the same mistake. I sometimes refer to indexes plural, but there's a single index really in Cosmos DB. So the use of plural is just to mentally align with how we believe databases work, really. Because in fact, if you come to think of it, there's hardly any major effect on adding a property. You add it and voila, you're done pretty much. So of course, there will be an RU charge associated with indexing that value, but it will happen immediately. In fact, I do encourage people to head over to aka.ms/cosmos-db-indexing, which will actually take them to a Microsoft Docs article, which tells them so much more on the entire benefits and how indexing should happen. And there's even a troubleshooting query issues and whatnot. The concept of this inverted tree, by the way, is both super powerful and quite technical, but I find it useful to think of each value as kind of a link to a specific location in the backend where the value really is at. Yeah, that's right. I was just about to type in this URL. There we go. So, Hasan, if we are going to use a composite index, let's just say you have this query right here, which filters by name and order, orders by age and descending order. The query is going to work as is with the default indexing policy, just fine, right? Or even with the custom one, it will still work as the one that we see here on the slide deck. It does work. What is the reason for using a composite index then?
So the main reason for the composite index is, in this case, we are using two properties, right? So if you are using more than two, like 3, 4, 5, because let's face it, usually that's very simple query, and you usually kind of look for many properties. So your statement is much complex than this. So if you have many properties, then you can actually put them together as a composite index, and then it's gonna make everything is much better, because in this case it's gonna use the C name and CH separately, so it's gonna use two separate indexes. But if you can create a composite index, it's gonna use just like one index type, I guess, and it's gonna be much faster. Well, so let's actually go back one step.
Sure.
It will make it fast if you have one physical partition, right? So don't forget, Cosmos DB is a distributed database. So that means you might have 5, 10, 20 database servers or replica set, which call physical partitions in Cosmos DB. So that indexing policy you see out there is going to exist in each of the physical partitions. So I am hoping the name is going to be our physical partition, so we can actually go hit one physical partition and run this indexing policy, so we don't have to run this query in many places. In that case, if you are going to do that indexing, I'm not sure how much is going to actually help you. You can have the perfect indexing policy, but if the physical partition is not in that where clause, even everything is perfect, we are really looking somewhere like 2.53 request units. But if you have 20 physical partitions, you need to multiply that with 20.
Mm-hmm.
So I want to kind of make that clear too, because like indexing, not just like the SQL Server, it's not like a global thing, it's per physical partition.
Yeah, and coming to think of this example one more time, even though everything does work with the defaults, the way I think about composite indexes is just like a set of properties that they're putting together in this supposed inverted tree. And every leaf in this inverted tree is either, if you use this range index by default, is going to be a single property, and we're going to effectively traverse the tree based on the values that we see with those properties. Or if you use a set, it's going to be the combination of multiple values together, ordered in a particular way, ascending or descending, which help us understand where exactly the data from the document exists based on these combinations, these sets. But here's the problem, and I think you did a fantastic job talking about if you have a single partition or not. The idea is that as data increases over time, in this particular example, especially if the amount of people who are named Mark would increase over time, the RU charge of this query would increase quite a bit as well with the default indexing policy, because we would only have the policy on, say, name. But now we have pulled a lot of data which is unordered, and which means that we need to consume CPU to have it ordered. The alternative would be to use a composite index, which retrieves our data in an ordered fashion pretty much out of the box, right? So if you have a lot of data, and when I say a lot of data, I mean like probably up to terabytes of data, this query might even cost you thousands of RUs to execute a single time. And that's the reason for why composite indexes exist in the first place. Hopefully this makes sense. So for that particular query with c.name equals mark as an equality filter, and then an order list on two properties, the name ascending and the age descending, you want to create a composite index by name and age, and you specify the name in ascending order and the age in descending order. And if you have this composite index used by your query, you'll see the RU charge drop quite a bit. In this particular use case, the query engine is actually able to make use of the composite index for evaluating the filter and evaluating the order by clause, which makes it a lot more efficient to use the index in this query, since you're able to just use a composite index for evaluating the entire query from a single shot. I'm just going to go through these slides quickly. But similarly, if you had a query that averaged age among all employees, this would be another great instance for a composite index, because we have here a filter and an aggregate together. So in this case, you want to create an index in the company and then the age. And as a third example, if you had, for instance, a query that filtered out the name and filtered out an ID, you could, for instance, create an index on the filter and to filter on the name and the identifier to improve the query performance. One thing I want to take away from here is the emphasis on composite index, because we're not talking about something which is required, but rather something which tends to improve the query performance when you're operating at medium and large scale with Cosmos DB. And the general rule of thumb is that the more data you have, as well as the higher the cardinality properties you have, the more impactful a composite index is going to be. So if you have the ID property has low cardinality, and I know this doesn't make a lot of sense, the composite index will not help much. It will definitely offer some improvement, but it's not going to be like a night and day change. It's not going to offer you huge, extreme difference. ID, of course, tends to be a property with a pretty high cardinality typically. So you typically see pretty much improvement there. Let's put it this way. Anytime you're dealing with data model that has a property like identifier and timestamp and zip codes and address and names, and these tend to be really high cardinality properties. So if you have queries with higher charges with these types of properties, and they have multiple filters, they have order by maybe even, these are instances where thinking about the composite index will help out a lot from the performance perspective, from the query performance perspective. We actually have a fantastic question from Jose on YouTube who asks, what are the differences between creating an index for Cosmos DB when using MongoDB APIs or Cassandra APIs? You want to take that one?
So creating indexes using MongoDB APIs or Cassandra APIs. So we are really dealing with the same indexing policy. And I don't really think that there's that much differences.
Well, really, the major difference comes from the API itself. If I would take my stab at that question, because the Cassandra API is designed to store the data in a columnar format. So in Cosmos DB, Cassandra actually leverages the underlying index and infrastructure that Cosmos DB puts together for the purpose of exposing the indexing strength that is inherent in the platform of Cosmos DB. So unlike SQL API, or which we're talking about right now, or MongoDB, which is actually very similar in that regard, Cassandra API in Cosmos DB does not index all the attributes by default. And instead, what it does is that it supports secondary indexing to create an index on certain attributes, which behaves the same way as Apache Cassandra. In general, at least based on my knowledge, it's not advised to execute filter queries on the columns that aren't partitioned. Rather, you would use a so-called allow filtering syntax explicitly, which results in an operation that may not perform very well. And in Azure Cosmos DB, you would run such queries on low cardinality attributes because they kind of fan out across the partitions to retrieve the results. And therefore, it's not advised to create an index on something that frequently gets updated as a column, I mean. And it is prudent to actually create an index that you define the table with. And this ensures that the data and indexes are going to be in a consistent state. So in case you create a new index on the existing data, currently, there's no ability to track the progress charge for that table when you use the Cassandra API. So that's going to be a bit tricky from that perspective. If you need to track the progress overall for the operation, there is a request that you can run to progress the charge using a support ticket. But I mean, who wants to do that? In my opinion, at least, it feels a bit over the top. So there is indeed, Jose pointed out this really, really well. There is a bit of a difference from the Cassandra implementation, but merely because of the API, not necessarily the platform. The platform handles everything mostly the same. Hopefully this answers the question. Cool. So with that very quick, roughly quick intro on indexing, maybe it is a good time to talk about tracking the indexing progress. Because when you change your indexing policy, it's pretty much hard, if not impossible, to break things as a developer, optimizing the indexing policy and whatnot, unless the indexing policy that you're working with has a problem. And then, of course, the problem wasn't the transformation, it was the indexing policy itself. But in other words, when you change your indexing policy in Cosmos DB, there's no actual impact on either the write or the read performance. So I had the default indexing policy, for instance, and then I decided I want to, instead of include everything, I just wanted to exclude everything. And I want to instead index just by name. And by saving that, I'm going to have an indexing policy transformation process that would be done without any impact on the performance or the availability of both the writes and the reads. Because if, for instance, I had a query that would use the name property, which is just included, the performance wouldn't be impacted while the indexing transformation is still occurring. You need for that index to be fully updated before it can actually be utilized. And up until that point, or up to that point, there's going to be zero impact on either the performance of your reads and writes because the index is simply not used. So when you're making an index transformation, there's actually like a yellow banner in the indexing policy tab, which sometimes even shows you at which percentage transformation is at if the transformation is taking longer than that. So there's this concept of metrics, which return typically 4 properties back to you, and they return the utilized single indexes, the potential single indexes. These are recommendations, of course. The utilized composite indexes and the potential composite indexes. And the whole idea here is that if you see an index being utilized, that is evidence that the query engine used that specific index path. In other words, the path that a query engine needs. And the other metric is both of the metrics which contain the word potential. And you should think of this more like an educated guess, something that is calculated, because there's no certainty that if you use these paths, the query engine would even use them, or that you would improve the performance. But there are some internal heuristics that Microsoft utilizes, which makes the recommendation reasonably confident that by adding these indexes path, they'd be utilized and improve the query performance overall. I'm going to skip some of these slides, mostly in the interest of time. And I do want to rest assured the audience that if they actually go back and watch the recording from last week on utilizing indexing, they will actually come across the topics which literally touches on how to manage and how to monitor the utilized indexes. So that being said, Hasan, how do we customize indexing policy?
So that is a tricky question out there, right? The easiest way is just go to the Azure portal and you will create the indexing policy. It's already there, so you can just change it from the UI. That will be probably the default way to do things. You can do that in SDK, but when you do from the SDK, it might not be, how are you going to track all the changes, right?
Right.
So always good to have like an indexing policy in a JSON file, like put it in the solution somewhere, and it will be in your kind of source control somewhere, so it will be always there. But you can do that by the code easily if you want to do that. So those are JSON. Yeah, those are the 2 ways you can actually do the changing the indexing policy. So I guess I can maybe show you on the portal how to do this.
Let's do that.
All right, so let me actually open here my portal. So as you can see, we are looking one of my databases. And actually, let's open this one here. So we have the database. This is my container. You go under the scale settings here. and indexing policy is one of the tabs on the top. So as you can see, I have a couple of indexing policy items here. So I have some excluded paths, include paths, and composite index here. So the easiest way to change this, you can just add new paths to any of those items. And after that, you can just click the Save button. Then reindexing will get, I guess, fired up. And that will be the probably easiest way to actually go and change your indexing policy.
Cool. That's pretty nice. So maybe let's start with a simple JSON document as an example. On my slide deck here, I have a JSON document which has multiple properties. But the goal here, if we are to give ourselves a goal, would be to index the category name and the name properties for the purpose of actually writing some queries that would be a bit more performant, maybe by utilizing these indexes. And what we see is a document that contains, in this case, a product where the name of the product is HL Touring Frame Yellow 46 in the category of components touring frames, right? So obviously it's a bike. So in raw JSON, the indexing policy would probably start by excluding all possible paths and then opt in to include the name and the category name paths only. And you see that here on the left side of this particular slide. Now, we haven't done much to this point, right? Because unless we figure out a way to utilize composite indexes, we're going to write the query as such. By being a bit more specific on these two properties, the only thing we're doing is that we're excluding all the properties that are neither name nor category name from being indexed. What are we actually doing? We're just cutting down some of the RUs when you're writing a new document. That's pretty much it. Like, it stops here. However, the .NET SDK actually ships with a Microsoft Azure Cosmos Indexing Policy class, which is a representation of your typical JSON policy object. And when you're creating a new instance of a class, you can immediately set the indexing mode to automatic and automatic properties, much like their JSON counterparts. And in this example, the indexing mode here is pretty much set to a consistent and automatic indexing enabled, like the one you see in this code snippet right here in the top. And the class also includes an excluded path collection with an add method to add new object of type excluded path. In this example, we're going to just exclude everything. So what effectively you see on the left and the right-hand side are the equivalent of effectively enabling the same JSON. Hey, Hasan, is there a way to write C# code in the Azure portal and configure it like I would write C# code, or do I have to stick to JSON?
So in the Azure portal, as I know, I think it's just a JSON. You can just go to indexing policy and just change the JSON object from there.
That's right.
There's, I think, ARM templates that I think you might be able to do the indexing policy, but I really don't have that much experience on that.
You definitely can do it in ARM as well, but I would be mindful about the escaping that you have to do with JSON, because remember, ARM is JSON based. So if you want to write JSON in JSON, that is actually going to be formatted and parsed correctly by the data plane API connections, controllers or services of Cosmos DB, you'd have to first escape the JSON represented the indexing policy in order to inject it in the JSON represented the ARM template. And it can be a bit of an inception. And obviously, things can be a bit erroneous, therefore.
Yep.
Cool. So now that the indexing policy is configured, I guess the container properties class is going to be utilized to configure the properties of the container, such as the name and the partition key, and most importantly, the indexing policy. This class then is passed to create container if not exist method as the first parameter to create a new container with the custom indexing policy, just as you see it here in the code on this code snippet. I think this is super straightforward, and the fact that you can configure through C# the same thing that you could do for JSON gives you a lot of flexibility in terms of automation and, well, implementing some sort of a programmatic change to your indexing, depending on how you deploy your code, how you deploy your data, how you update your data, and so on. So I think this is really powerful stuff. Now,
yeah,
sorry.
Good part of this one is, if you're a programmer, C#, you can do this very easily. If you're a DBA, you are kind of lost right now, right? So that's why I say that, you can still use the Azure portal to do everything that we just show you here, and you don't have to know the C# to actually maintain the Azure Cosmos DB. So I just want to kind of make that clear too.
I think that's a great point. Do you want to talk us through the indexing policy for spatial data maybe as well?
Sure. So let me actually start with some of the examples that so far what we talk about. So I have my application here. This was a VS Code extension. You can download it for free if you like. So this is one of the, I guess, the problems. We usually, we talk about this SDK and we talk about all the great features, but most of them, to actually be able to use them, you need to know C#, and you need to have the SDK open so you can actually run those comments and actually look at the headers. When the header comes up, you can actually see, for example, what's the reindexing percentage and other stuff. So there's not like a UI which can actually give you all those information. So that's why I'm going to try to show you this rather than SDK code.
Okay.
So
what is the name of the extension again?
This is a Cosmos-db, Savran Web Cosmos-db SQL Studio.
Mm-hmm.
I had to think about it there once. So let me actually look at the first thing that thing is going to ask you is what is your connection string. So I am going to actually just pass my connection string here, and I'm just going to connect to my Cosmos-db. The first thing you are going to see, I have a couple of databases here, and I'm going to open the Stack Overflow, and I have one container here. Now, before I start to do anything, in Cosmos-db, it's a distributed database. There are physical partitions. This is going to tell you I only want physical partition, so I don't need to worry about any kind of, I guess, yeah, it's important to put the the partition ID, but since I'm always going to hit the same partition ID, it's the things are going to be much easier in this case.
Mm-hmm.
So let's actually look at, let's say, select top 10 with a simple query and just run it. So this is going to give me select top 10, and I want to kind of show you some of the stuff that usually you cannot really see as a DBA, or if you don't know the C# that much, because for example the execution metrics here, right? To be able to see them, you can go to Azure portal, you can see them there, but you can actually see that with this tool, and I'm going to try to explain some of them here. So the first thing you want to look at here is indexed documents. That means I am getting 10 documents, and they are coming from indexes. So that is good. I'm happy with that. Also, I can look at the indexing policy here, and I see some of the properties are excluded. One of them is the score. Now, if I look at the score, it's right here. So if I'm going to actually try to use the score in my query here, let's say score is larger than 200, and run this one, the number went up pretty high, almost double, maybe more. If I go to execution metrics here, you are going to see that I am retrieving all this data, and you see all kind of information here. If I'm going to actually make this, let's see, change this one to 364, for example. In this case, this is 364, and execute it again. You are going to see that whatever is coming here is not coming from indexes, and you can actually tell. My request charge went kind of crazy here, and index hit documents is 0 right now. So that's pretty, I guess, simple example. But I want to actually show you one more thing here. Let's try to make this a little bit more, I guess, complex. So let's say we are going to look for date, because I think we have a date here created on. So let's look at and start with that. Let's say we are looking for data. Let's say 2008, since this data set is a little bit old. Let's start with this. We execute this, and it's 477. So now, we talk about indexing metrics. You can actually go here to options and look at the display indexing metrics here, and you will see a new tab coming up. Right now, there's nothing. I have to execute this again, so you will actually see that created on is getting used, and you don't want to lose this. So you don't want to remove this and put this in the excluded property for sure. So let's try to actually make this a little bit more complex. So let's say we are going to look at for score 2, and let's say score is larger than 0. Now, these are my results. And let's execute this. So 479, and if you look at here, score is excluded. And actually Cosmos DB tells me that, if you actually put the score here, probably I'm gonna able to use it. And probably you're gonna pay, less request charge if you will actually go and include the score properly. You talk about the composite indexes, right? So I guess to make this one a little bit more complex, let's actually even add order by. So let's say we're gonna do credit on and score. Actually, let's take the score out first. Now, if I execute this, we're gonna see I'm running for 357. And if I'm gonna actually add the score on top of that, we're gonna actually see that now I'm hitting the composite index. I have a composite index in this container. And if I actually go back to my Azure portal, you will see that I have credit on and score. Both of them are scanning. So my query is matching perfectly here. As you can see, credit on, see score is here. And since the order is right, actually I am utilizing my composite index. So composite index, that can be tricky. So whenever you actually declare the composite index, you want to be sure that your query, where, and order by, they are going to actually match the signature of the composite index. So this one actually gives you, I guess, that example.
I guess this takes you takes you back to that requirement of knowing your business requirement so that you know what code you're writing for. Because just coming up with ideas of composite index would be counterintuitive and counterproductive, because you, again, just waste our use if you don't utilize those indexes. And not utilizing them means that you're not using the best benefits of combining properties together into a single set, aka composite index, which implies that you're going to have a high RU charge, especially for that kind of data, which would have a high cardinality as well. A very great example. Thank you for that.
Oh, no problem. I have actually one more example here. So let's actually look at this one here. So this one actually does not have any composite index on it. So those properties we are looking at, I don't have anything. So how about actually creating one, right? So let's actually write this one and start maybe just this query here. And let's see what we're going to see here. When I run this, as you can see, potential indexes. It tells me that if I actually create a composite index on answer count and create it on, probably Cosmos DB is going to use that, and we might be able to see maybe a better request unit. Also, if I'm going to try to run this, Alex, what do you think is going to happen?
With a composite index, most likely your RU charge will drop.
Without the composite index. So we don't have the index. Yeah.
I would expect it to increase quite a lot.
You are correct, but in the meantime, since I have two properties here, order by, this is not going to run.
Oh,
it's going to tell you
better.
Because you need a composite index to actually be able to use the order by with multiple properties.
So I think that's an interesting selling point here, because if you did not order that, the query would run.
Correct.
But by adding the ordering capability, the query doesn't run anymore. Correct. And I think this is interesting, because the reason for having the order there is just to ensure that your output is in a particular sorted list, right? If we only keep the data that on the indexes that we're utilizing in an inverted tree, and we do not utilize a composite index to enforce the ordering or sorting, ascending or descending, the data that we'd retrieve would be random. I mean, random to the point as what data was recently added would just come later on in the actual result that we're querying the data against, based on the indexes that were actually utilized, the range indexes that were utilized. So if Cosmos would have had a way to order the data without a composite index, what it would have done is to implement some sort of a sorting algorithm on the actual result, which did not use a composite index, but that means a lot of CPU consumption, which implies higher latency and a lot of RU charge. And we want neither of those, right? So rather than actually running and increasing the RU, and therefore you paying more and increasing the latency, they simply don't run it, and they tell you need to implement a composite index. And frankly, I kind of appreciate that, because otherwise anyone would write just any crazy complex filter, any complex query with complex filters inside them, and never leverage composite indexes, and they would just complain that their RU charge is too high.
Yep, I agree. That's correct. So if I'm going to actually go and run this one, as you can see, it's going to run that because I have only one property, order by. But if you want to add more properties, you are going to need a composite index for sure. So in this case, let's actually add that composite index. So back our portal, what I'm going to do here is, well, I was going to type it, because when you type it, actually, it looks better. But I'm going to just copy and paste since we don't really have that much time, and I'll explain that to you. So I'm just putting a comma. I'm putting a new array. As you can see, my path is answer count, order is ascending, and path is created on ascending. So in here, I'm just going to click save, and that is going to actually trigger reindexing. So let's do that. And when this is actually happening here, you are going to see soon that this is going to change, and you can just kind of check where the reindexing is. As you can see, refresh it. So you can do this if you like, or you can have in here, actually, I have an application which actually runs and looks at the index tracker. So this is going to actually, what it's going to do is it's going to try to run a query, and it's going to put some header out there, and it's going to say true. So this is going to actually tell you, for example, current index transformation is 49. That's going to actually run, I think, every 10 seconds and check out if the index transformation is complete or not. So I have this code here. You can just look at it. So we have the container response, and as you can see, I'm looking this header here. This header actually has that number that I was just displaying. And then when this actually hits the 100, it just stops there. And you can actually see we hit the 100. It took 17 seconds. This is a pretty small container, so it doesn't take that much time for reindexing. So now we should have our reindexing done. Now, when I actually go back and run that, you will see that potential index should not be there anymore. We're executing. As you can see, it dropped almost half. So I think that's a win-win for us.
We had a 5 something, like 522 or 552 or something like that. Now we are at 3.22 RUs instead. And I can only imagine, had you had the larger data set, which obviously would have implied longer index transformation index policy transformation times as well, the RU would be even more impressive. The RU drop that you're getting there would be even more impressive.
Will be. Well, actually, that's a good point. Let's actually look at it. So container is a small container, right? So if I actually go and look at big container, which actually has the same data, structure, but different data. So for example, let me actually go back and run this one first, the old one. So I'm just looking, for example, this. Let's run that. And this one gives you, let's say 5, just to be, simple. Now I'm going to go back and run in the big container. Now, big container, if you click here, I have 5 partitions, which means the post ID tells me that the partition ID is the post ID. Post ID is not here, which means I am going to actually go and run this. It's going to be a cross query. 477. Now you end up with 25.
Yeah.
Indexing cannot help you with this. Why? Because you can actually click here. Each of them actually costs you because if you look at it, it's 5, almost all of them are 5. You can try to kind of make maybe indexing better. Maybe it will say you 1 request units for each, But at the end, you are still going to pay like for some of them, right? Total of them. So indexing is important, but if you have the partition ID, it's going to actually help you much more than indexing, I guess.
Because by having the partition ID, we can ensure that we're not utilizing any CPU or IU on any partitions that do not contain the data that we're looking at, right? And again, this takes us back to that importance of data modeling. If you cannot write a query that does not run on every single partition, then your data model probably has room for improvement, because you haven't put effectively your data in the right buckets. Every time you need to search for something, you need to search everywhere, which is wrong. You don't do that in real life either. When you know that you've lost your keys and you typically put your keys in one place, you look in that place first and foremost, or any other places you typically put them. You don't start searching for your keys in your sockets drawer, for instance.
Correct. And actually here, if I run this one, select top 10, I don't have any filters, right? Execute it. And if you look at the execution, we are hitting 50 because we are running that in every partition here. You are getting 10 from each. And each of them is actually costing you request units. So you need to actually pay for, all of this, not just one.
Totally.
So that's, I guess, one of the biggest differences between, distributed database and relational database, which is one. So I think that's all I have from this demo.
Shall we maybe talk about the way you would evaluate composite indexes real quick?
What was that?
Shall we maybe talk about the evaluation of composite indexes? Like when to utilize them, how you can utilize them, in which cases you use each one?
So really on this, I guess, demo here, if I go back here and look at them. So right now, for example, we created one here and we were looking answer count and created on. And if I actually run this and execute it, well, I'm in the wrong one here. That's why it says you cannot run it. So when I run this one, as you can see in the index and metrics, we are hitting the composite index here, answer count, and credit on. So as I said before, it's important to put them in the right order. That's one of the important parts. And if you're going to have like many properties here, you are going to actually see them under the potential indexes. If you are using the SDK, you can see the index and metrics. I guess that's a good question, maybe, Alex, for you. How am I going to know which query is the worst query? So I can actually go and look at it and figure out if I need potential indexes on it.
Well, I think there are multiple ways to achieve that. There's diagnostic logs, and then there's the metrics that you could be looking into. I would personally go for diagnostics first and see what's the worst quote unquote query in terms of probably RU. And then I would look at the metrics on that particular query to understand what exactly I'm failing on. Maybe I'm missing indexes. Maybe if there is a potential composite index or a potential range index that could be utilizing, that might be missing because of one of those include everything or exclude everything that I did incorrectly. Would you do this in any other way?
No, actually, I will do the same thing. But there are some devs out there which is actually they track those audits in their end, so you can actually look at your database if you're auditing everything. Some people do that, and really, I will do the same thing.
Yeah, that sounds great. Now, I think that we did a great job explaining composite indexes, but there are some particularities about utilizing composite indexes, aren't there? Like you can't just put everything in and just think of that as a composite index. So if we take a look at this example query right here, select star from products where the product name equals road saddle and the price is greater than 50. We have two filters here, right? We have an equality filter, which checks the value of the name property and the equivalency of the string road saddle. And we have a range filter on the price that checks to see if the value of the price property is greater than 50. So if the query is able to use a composite index that includes both the name and the price, the composite index would be just one which you define on these two properties, name and price. But one thing for people to remember is that when you use a composite index, you can and should also specify the ordering. So one interesting or neat thing about composite indexes is that you can have two different combinations. You can have name in ascending order and price in ascending order, or alternatively, you can have name in descending order and price in ascending order. Do you know why you can have both ascending and descending for the name property, but not for the price, for instance?
So that's going to really depend on how you create the composite index. So in this case, if you're going to put the order by, both of them are going to be ascending. So if you're going to try to change a structure, and if you think that you are going to actually hit the same composite index, you might be actually surprised. Your composite index signature must kind of match your filter and order by kind of orders.
Yeah, absolutely. And if you are only using equality filters, whether they're ascending or descending really doesn't matter. But one pro tip, recommendation, and I might be wrong, so take this with a grain of salt, but I even think it is a requirement, is to always have your equality filters first in case you're using multiple filters that will average a composite index. And therefore, the range filters would appear last. Now, if we are to go even deeper, queries that order the results using multiple properties must actually include a composite index, just like we have seen previously with Hasan's demo. So here's another example. In this case, we look at a select star from products, and we would just, actually, I'm missing something here on this one, because I would also order I just realized that we have an issue here where the keyword should be ordered by rather than where, and price is ascending and name is ascending. So the composite index that we would be utilizing here would be one that would support this query, but it must exactly match the sequence of the properties in the order by clause. Again, this is not a where, but an order by. And the composite index of name ascending, price ascending would work. It would not work, actually, because the name is the second one in the list, right? We have to match the list, the order in which the properties are configured in the composite index and are going to be utilized. So the only composite indexes that would work here are price ascending, name ascending, or alternatively, price ascending, name ascending at the same time. You can also use composite indexes with queries that have different permutations of filters and order by clauses and so on. And if you are to create a raw JSON indexing policy with a composite index, you should probably include the optional composite indexes array property. And this external array consists of like a series of internal arrays for each composite index definition. And again, you can go crazy with them if you want, but you should, in my opinion, you should only configure or explicitly configure those for which you know you write the query. I don't know if there's a best practice. Maybe Hasan, you can share some of yours. But knowing what queries you're writing is important for creating these indexes. One thing I see a lot of customers struggle with is that at some point they drop some of the queries because they no longer have that macro, they no longer have that code, and they leave the composite indexes there, which effectively implies that whenever they do a new write, they're going to increase the RU charge. Is there a good way to determine which composite index is no longer utilized and should be squashed from the policy definition?
So really, I think the only way I can think of is using the indexing metrics in some way and kind of audit that in some way. So you can have some kind of, I guess, job which can compare that maybe once a month or something. That's the only way I can really think of, unless there is something in Azure portal, maybe there's a way you can kind of compare them.
That's literally the way I do it myself. I'm just comparing over time the metrics, and in case at some point I realize that things have changed, maybe through code and whatnot, and I see the metrics also change occurring respectively, I think it's just fair every now and then to go through the composite index definitions, understand when they're utilized and when they're not. And if you do allow yourself to have a dev and test environment as well, which obviously is highly recommended, especially in the cloud, then, well, just try, how do they say, test the water with your toe, try the water with your toe. Just remove some of these composite indexes, and you might be surprised actually sometimes to learn that you're decreasing your RU consumption on the writes because you're removing composite indexes that are no longer utilized.
Yep. And also, I will add one more thing here. Just because potential index suggests you to create an index, you shouldn't just go and create one. Just like SQL Server kind of suggests you index, that doesn't mean that SQL Server might use it. So just test that before you put it in production. And the other thing is, like, whenever you are doing an index changes, try to do them same time. Don't kind of go and change the JSON policy like for each, I guess, index. It will be much faster if you actually put all those index changes once and just kind of run it.
Yeah, and previously when I showed you those examples, I had to think for a second there what combination of properties in what order and in which sending sorting would be valid composite indexes. And this table right here is yet another proof of how difficult sometimes it can be to write a composite index. Here we have a bunch of query on a scenario with a query with a filter and an order by, where you're utilizing multiple properties at the same time, and you're using range indexes and composite indexes. You can use a bunch of those. This table actually shows you when composite indexes are supported or not. And there are definitely some considerations to take into account when you're creating a composite index, which is obviously, again, just to optimize the query with a filter and an order by clause. For instance, if you do not define a composite index on a query with a filter on one property and a separate order by clause using a different property, the query will still succeed, but the RU cost of the query will be reduced had you had a composite index, particularly if the property in the order by clause has high cardinality. And these are things that many times don't necessarily can like sniff when you're writing your code, unless you have some real data or real-like data, mock data, but which mimics the real world. And therefore, trying to test, at least to an extent, something which resembles the real data, real production data, is going to be very, very important. And similarly, if the query filters on properties, these should be included first in the order by clause. And along the same lines, if you have multiple properties that the query filters by, the equality filters must always be the first ones in the order by clause. For instance, the first sample that you have here uses both an equality filter and a range filter. As you can tell, we have the timestamp. This is always a bit confusing, isn't it? We have the timestamp property, which is ascending, and then the name also in ascending order. And we have put the timestamp, which is a range filter, the first one, rather than putting the equality filter, which is name, as the first one. And what this means is that we cannot use a composite index, again, because if we do have multiple properties in our filters, like in this where clause right here, we must make sure that the equality filters must be the first one in the order by clause as well. And the name is the equality filter. So there are things that you think would be like synonymous, and they're definitely not. And I don't know about you, but it doesn't always feel super natural when you're writing these, up to the point where you actually execute the query and you're all surprised, hey, why is my composite index not utilized? Or why is Cosmos-DB saying that I must implement a composite index? Because I already have one, right? So going back to the drawing board, even to this table right here, is something that I would definitely look into and be mindful about.
And also, I want to add, like, Cosmos-DB is much newer database engine than SQL Server, so I'm sure this is going to get, much better. But for now, we have those rules that we kind of need to follow for composite index to work, I guess, fine in the code.
Yeah, but generally speaking, there are only like 4 rules anyway, and definitely there is room for improvement in the experience. But as long as you can follow these rules and you use tables like this one that you see on this webinar, you're definitely off for a good start, because hey, if I'm trying to do a similar thing like they did over here in this video, I know that this is not a supported scenario for composite index, so I know how to move along and effectively apply that same logic and same mentality to my own applications and to my own queries.
Yeah.
Cool. Now, I did say previously that this entire lesson today is actually, like always, obviously, following the Microsoft Learn module with the same name. And there's obviously an exercise on configuring the Azure Cosmos DB SQL API containers indexing policy using the portal. Hasan, you already did that several times, so in the interest of time, I say we skip this one. But I do want to remind people that they don't need to have an Azure subscription in order to get their hands dirty with Cosmos DB and in order to get their hands dirty with the material that we have actually covered today. Everything is completely for free, even when it comes to spinning up some sort of a sandbox environment, which is a real Azure subscription that you gain access to, where you're following the instructions on configuring the indexing policy or whatever else that you're actually working with or learning about in Microsoft Learn. There's nothing that you need to pay for. There's no credit card required. There's no Azure subscription required. As long as you have a Microsoft account, which you can sign up for completely for free, you're good to go and you're up for the races.
Also, you can use the emulator too if you like.
Oh yeah, totally. Shall we go through the knowledge check maybe real quick?
We can do that, or I can just jump in and show you the geospatial before, since we.
Oh, you know what? I'd love that.
Yeah, let's actually do that very quick before I guess we go in. So, geospatial data type is different data type. So I just connected a different database here, and let's say, for example, this one has all the hurricanes. I'm just gonna go and say select top 10 here, so you can actually see what it looks like. In Cosmos DB, it's a GeoJSON, so you can actually see we have a location, the type is point, and we have a couple of coordinates here. So if you don't, I guess, do anything, if you look at the indexing policy here, we don't have any geospatial indexes. So you can actually create it, and let me actually go here and just quickly change my database to geospatial data, so you can actually see it here. And so I'm looking at the hurricanes right now, and if you look at the scale settings here, when you look at the indexing policy, we have only one kind of, I guess, type of indexes for that. So let me actually look at, I think this one has it. So as you can see, I have the spatial indexes here, and I am indexing all the points, polygons, multi-polygon and line string. So we are not really defining where these are. Cosmos DB will find them and just do the indexes. So actually, if you go back to the application here, and if you look at the map right now, so I'm just take this off. This is actually going to show you Hurricane Katrina's path. So if I execute this one, it's going to actually find all the geospatial data, and it's going to actually show all of them. So as you can see, it's 2.89, and it's not really that bad at all. And you can do much more than that. And for example, let's clear that up. You can use the geospatial functions. Let me actually click here so you can actually see the query that I'm going to run. So I'm going to do this. As you can see, I am running that st within function, and I'm passing the polygon, which I just draw here. So this one actually goes and finds all the geospatial data, or the data I'm looking for, in this box here. And as you can see, request charge is 545, so it's not really bad.
That's pretty cool. I particularly appreciate the integration they did with the extension. I mean, it's much more eye candy, obviously, and the experience is improving by an order of magnitude when you utilize this. Pretty cool stuff.
Yeah, no, thank you. I mean, I have more stuff here, but I think maybe next time I can show you more stuff here.
Can people follow up with you, maybe on Twitter?
Sure. Yeah, of course.
Sweet. Yeah. Let's go through the quick knowledge check. We have 2 questions. I'm going to take the first one. You're writing a C# application that interfaces with Azure Cosmos DB SQL API and are not tasked with creating a custom indexing policy in code, but which class should you use to author a new indexing policy and customize the indexing mode, enable automatic updates, and set the include-exclude paths? A, indexing policy, B, container properties, or C, indexing mode? What do you say?
I will say it's not, for sure, it's not indexing mode, I guess.
Right. Would you care to explain why?
Because I think indexing mode is part of indexing policy, so that shouldn't be the one for sure. Indexing mode, I think, is consistent or none.
So I think this is a long question, and there are some keywords here, right? We write a C# app. We are not tasked with creating a custom indexing policy. We should use a method to author a new indexing policy and customize the mode, enable automatic updates, and set include exclude paths. So I fully agree with you, actually, Hasan. I do not think it's the indexing mode because it's just a mere property part of another class. The container properties, I mean, yeah, there is such a class, but where did they even come from with this one? Because the container properties is what we want to configure on of a particular type, right? If we are to refer to our previous example there. So I would actually go with indexing policy. What about you?
I agree.
Let's see. We're going to lock that answer in, and drum roll. Sure enough, we're correct on that one. Want to take this question maybe?
Sure. The question is, the most used query in your azure-cosmos-db SQL API application is select all from products, order by name and price. You will like to define a composite index to make the query more efficient and consume fewer request units. Which composite index should you use to support this query? So if I remember right, things has to be in order, right?
They do have to be in order, and we have to look into the order by clause. So we have name ascending and price ascending, which pretty much rules out, in my opinion, both A and B. This goes back to those rules on configuring composite indexes on multiple properties. And when you have them used both in wheres and order bys and this and that and yada yada, there's actually a good article on this one, and I would encourage people to actually look into that one. I'm going to share this with our producer, and it will come up momentarily in the banner there. But this is definitely a good article that I would encourage people to go and head over to if they want to learn more about authoring these composite indexes correctly. And then if they ever watch the recording, just make sure you head back to Hasan's video, demo on how you actually can check which composite index and which index, generally speaking, is utilized and which is not, because sometimes you may have some surprises right there. So I would actually go with C, simply because of the fact that it's the only one which has everything nicely ordered in the list of composite indexes. What about you?
I agree. C sounds good.
You agree? We'll log that in, and sure enough, that is correct.
All right.
Cool. We also have a question from Curious Drive on Twitch. What's the best practice to generate IDs for new records? You want to take that one, Hasan, maybe?
Well, to generate ID, you can really use any way that C# actually, many ways to actually create IDs if you like. And if you actually keep ID empty, azure-cosmos-db creates record for you. Am I correct out there, Alex?
Yeah, pretty much. If you do not call it the way it should be called, Cosmos-db is going to pretty much shove you one in your face. So the one thing I think is important, just to make sure that you have an ID property to begin with. And then you're in control, so to say. By default, when they generate one, they generate a GUID. And I'm absolutely fine with GUIDs. I think, especially for Cosmos-db, they work fantastically. And I particularly enjoy them when you have multi-master implemented, because that means that you can have writes from multiple places. The last thing you want is to use an integer and then have two different places use the same identifier from two different containers and just create conflicts. You want to stay away from those. Sure, the correct answer would be it depends, really, because it depends on the scenario which you're implementing. Sometimes you want to query by the identifier by using a range filter, any new document that is greater than 1000. Maybe you write fiscal receipts from your fiscal printers or whatnot, and you want to look at the the receipts that were printed over after a particular time, and you want to look at the ID property rather than an actual metadata or the property of the document. It would be a scenario which utilizing a GUID for the ID would not be a good idea. But again, data modeling is such a big thing, it's such a big topic, that answering this question really it depends. But general rule of thumb, in my opinion, GUIDs, global unique identifiers, should be the way to go. Good. I don't know about you, Hasan, but I've had a lot of fun today, and I think we did a pretty good job actually at covering our objectives, which are, again, implementing a correlated subquery and creating a cross-product query, actually working with the indexes on configuring these. And if people want to learn more on indexing, I encourage them to actually head over to the topics that we have discussed, specifically on indexing policies in Azure Cosmos DB and managing index policies in Azure Cosmos DB. They can also scan this QR code and they can learn more for sure. Again, this was the Microsoft Learn module called Customize Indexes in Azure Cosmos DB SQL API. And I would tell and emphasize that this is a 15-episode series. So make sure that you don't miss the next one, which is going to be on April 6th on consuming an Azure Cosmos DB SQL API change feed using the SDK. Change feed is a fantastic feature. They don't get that in the relational world, do they?
They don't, but they are trying to find a way to do that for sure. But unfortunately, they don't have that right now.
No, they definitely don't. Hasan, did you have fun today?
Yeah, I did. It was great. It was a pleasure to be with you and with everybody else here. And I hope everybody, learned something new today. And you can, reach me from Twitter or LinkedIn anytime. If you will have any kind of questions out there, I'll be more than happy to, help.
Yeah, me too. I definitely enjoyed myself as well. Big thanks and hi to Chris for covering all the fantastic questions that we have got from our audience. And make sure that you stream in and keep on grinding and learning, because you definitely want to get certified. Hasan, maybe next time we meet, we're both going to be certified by that time. We're going to take our exams and pass them, hopefully. And we'll tell everyone about their experiences on our exams.
Sounds good. Yeah, it was great to be here with you.
Likewise. Until next time, stay safe, everyone.
Yep. Take care, everybody.